Hello, this is Hector Vladimir. Today is the 9th of August, 2024. Temperatures are high, up above the 36 degrees centigrade right now. That is close to 97 degrees Fahrenheit. Right now, it's about 5 p.m. in the afternoon. These temperatures have held for a couple of days now, and it is close to mid-August. So we'll see how the rest of this month goes. This has been probably among the hottest years in recent memory for the area, and all thanks to global warming. I want to discuss today a quite exciting project I have been working on, something that I have worked in the past before, but I'm now working on a different approach for this, and it is an efficient off-grid home design. I call it the Efficient Home Design Project, and it is, in simple terms, a home design for a specific area that is about as efficient as it gets as far as reasonably living with modern technology in modern society. Of course, the most efficient home ever would be a home with zero load, electrical or energy load, basically without any technology, but that is unrealistic in today's society, today's day and age. We have to have technologies. We live in environments, in times that demand technologies, and with that in mind, I did put together a specification sheet or paper that is of a home that is just about as efficient as possible. Again, staying within modern society, living in modern society, being part of it, working in it, and living with technology. However, you don't have to spend a ton of energy, ton of money. You don't have to be exuberant with the energy consumption. You could be very well efficient and very efficient at that, living in a home. And it could be very cheap to live in, very affordable, and again, energy efficient. So the project, I began putting it together on July 15, 2024. I am just going to be reading off of this design specs or specifications document that I have put together. Of course, every home is going to have different demands, different requirements, depending on the location where it's at. So if you have a home, of course, in Anchorage, Alaska, it's going to have different electrical, energy, heating, cooling demand as a home in Tehran, Iran. So you have to consider the location. This home, I have it for a city like Atlanta, Georgia, which is a subtropical river basin city with moderate temperatures, climate. The temperature range, I looked this up for this location in which the home will be designed to be built. The temperature range is from 0 to 40 degrees Celsius with an average temperature yearly, that is, of 25 degrees Celsius. The average insolation, that means the amount of sun that this area gets, is about 3.5 hours average per day per year. The average rainfall per year is 47.12 inches. The average snowfall per year is about 1.9 inches. Extreme temperatures are expected to happen about 40 days out of the year for heat above 32 degrees Celsius. Today being one of those extreme heat days, is about 35 degrees right now. And the expected extreme temperature for the cooler weather under 6 degrees Celsius is 30 days per year. And I will go through some of the other architectural style details. I did look at a few shapes for this home, and I wanted to basically decide and come to the conclusion which shape would be the most energy and otherwise efficient, affordable, buildable, and again accessible to be built. So you cannot only look at, let's say, efficiency, because certain shapes are very efficient, however they're not reasonably affordable or buildable. They are very complex, such as a dome. Those I have looked up in the past, actually, with quite a bit of detail. I have went into very significant detail and time spent on that, and resource spent on that project. I call it the Home Dome Project. If you haven't seen that design series of discussions, I would recommend you check that out as well. Not necessarily before this, but if you are interested in this type of very efficient home design discussions videos, you should look at that. I do recommend that. I have 2 projects that I have completed in the past. Design projects, those are not by any means construction, but the design stages of 2 dome structures I have completed, and I will leave it for you to check those out. I won't go into any details about that. So architectural style for this, I chose it to be a triangular extrusion. This is more like the architectural shape of this structure. It is a very unique and rare choice for architectural buildings or structures. If I could just define it without you looking at it, it is a triangular cross section which is elongated, meaning that it is longer than it is wide or high, with sloped sides. Basically, it is a triangular extrusion. If you know what an extrusion is, it's basically taking a triangle and extending it, more like a Toblerone chocolate bar. If you've seen those, you'll have a better idea of what the house or structure would look like. It would not have side walls. The side walls are actually the roof on each side, and that roof line is going to be, of course, covered on each end, completing the structure. So some more style details. The shape and orientation of the home will aid in energy efficiency by making use of interior natural lighting and shading, and make use of the greenhouse effect on its sun-facing side. Large clear windows, both on the sun-facing side and the front and rear of the structure, will allow lights and heat in when needed, and window blinds and venting will be used to dissipate heat. The dimensions of the structure: the height should be about 10 feet from the floor line or ground level, sometimes called the grade, and the length of the structure should be more or less about 30 feet. The floor line should be 24 inches above the grade. This will leave a 24-inch crawl space used for plumbing, wiring, insulation, ventilation, ducting, and ground clearance. The ground clearance is, of course, for the prevention of water intrusion during flooding events, snowfall, etc. This clearance from the grade to the floor line will be similar to a trailer or manufactured home. The orientation of the home, meaning the cardinal orientation of the home, will be perpendicular in relation to the sunrise and sunset, or with its long side facing north and south. This will provide the most sun illumination on the south side of the roof wall and the most shading on the north side of the roof wall. Again, I call it the roof wall because it acts as both the roof and a wall at the same time. This is probably one of the main reasons why I believe this shape choice is very good for a highly efficient home. I will go into construction materials next. The frame will be of lumber. I choose lumber and not any other exotic composite materials because lumber is very available, relatively affordable and cheap, widely used for construction, so anything else would be less available and more expensive. Yes, it is not the most optimal choice for environmental friendliness. However, it is, as of right now, one of the more reasonably cost-effective choices. Of course, if any of you out there would like to duplicate or approach the likeness of this design, you can choose whatever can replace lumber one for one. They have different sizes, standard sizes, which are also helpful to have standard sizes and availability for materials. That's why I chose, again, this shape and materials. But you can replace those if something of the likeness, especially with the size of the lumber available today. It could be some sort of metal, whether it's steel or some sort of alloy, composite material. You can very well do that and place one for one those materials. The interior floor will be vinyl flexible laminate, very widely available material in hardware stores and supply. The exterior walls will be vinyl covering, weather canvas, insulation sheets, plywood planks, fiberglass insulation blocks, which are to be placed between the frame. And the terminology for these may be a bit different. I'm not a construction contractor or anything like that. I am not going to say that I am any kind of expert. You should be able to find or know what I'm talking about by just me describing these. The roof walls are going to be built with asphalt shingles, weather fabric, plywood planks, insulation blocks, which will go between the frame, pads, column blocks because they're cut in rectangular pieces, but probably called pads, and they are 2 sheets of paper lined with some sort of insulation material such as fiberglass, fabric. So moving on to the interior walls, they will be made of sheetrock drywall. Of course, the frame I mentioned earlier was going to be lumber, so the walls will be basically the roof walls will be part of the frame. Further comments on the construction materials, the architectural style, shape, and materials choice are made due to their availability, relative low cost, and ease of construction. Although other shapes and materials may be superior in strength, durability, and efficiency, they're not as available, and their cost and construction may be difficult and of much higher cost. The length of the house should be enough to provide space for a 14-module PV array on the south side of the roof. The side walls at a slope will double as roof sides, as I mentioned earlier, and there will be windows on these sides, on the south side especially, but there will be also windows on the north side. Basically, the roof will have windows, the roof walls will have windows, and I do have some renderings showing, but I probably will draw or have someone draw a rendering for this specific house, since of course the specific details and specifications of this particular home are not going to be found on an online rendering where I can use it. Would have to basically do my own, and I will probably show that if I have it already on this chat. Interior temperature control, non-electrical air conditioning. So the orientation of the structure should provide control over natural heating and cooling. The shape of the house should provide some control over heating and cooling. So the orientation is going to have a lot to do with where the sun shines on the house and into the house. Of course, by placing the house with its long side facing south, you could have more surface area not only to heat the house but also to power the house using solar panels, which I'll go into a bit later. And I also put here that the shape of the house should provide control over heating and cooling as well. I believe this shape is very efficient, especially for heating the house during the cooler months, providing a very wide angled surface for the house to warm up during the cooler months. And having the roof at an angle, hitting basically the sun rays at a very perpendicular angle, it is a very good way to heat up that surface very quickly when there is sunlight during the cooler months. Now, during the hotter months in the summer, this would probably act as a heat sink that would basically overheat the house, you would think. However, this would be controlled by having reflecting window shades, or a window shades of very light and light reflecting colors. Also, there is an option to have white facing on that side of the house, basically white shingles on the roof walls on both sides. And another solution would be also by having solar panels on that side. There would be a lot of shine and heat reflected back, and the solar panels would act as a heat sink themselves, and the space between the roof and the solar panels would act also as a heat sink, cooling off, having that space, that gap, to not allow the heat to transfer from the solar panel surface to the roof. So I believe that shape to be quite efficient when it comes to temperature control. The ventilation methods of the house include venting and insulating the crawl space that's underneath the house, venting and insulating the roof and ceiling areas, also venting between solar panels and the roof. Also, there would be some tree shading, not a whole lot, some. There would be some palm trees, perhaps some trees around the house, providing a bit of shade to the area, not necessarily to the roof, but perhaps to the area of the house, perhaps the side, the front and back. As I mentioned, also window shading and venting, meaning that there would be window blinds that are light or reflective in color, and also windows could be open so that air could freely vent the home and cool it off. This venting not only could be the windows themselves, but also doors in the front and back, and also venting through the floor. Since the floor line is going to be high above, about 24 inches above the grade, there's plenty of space to bring air in and through convection cool the home by venting. There will also be, for the cooler months, a window greenhouse effect. Having large windows on the south facing side, especially on the roof walls, will allow plenty of sunshine and radiation, light radiation, to come in and heat the inside by a greenhouse effect. The windows should have clear double insulated glass. This should be sliding windows, probably better to slide side to side. And they should have larger windows on the south side and smaller windows on the north side. The north side, there's an option not to have any windows on the roof walls, since the less windows you have, probably the better to prevent any kind of leakage. They should have clear insulated double glass sliding windows side to side on the long sides, with large windows, especially on the south side, and small windows on the north side. This is to sun warm the interior during cold weather using the greenhouse effect. Further, window blinds and partially open windows can prevent overheating of the interior in the warm months. The north side windows are optional, and not having them will limit chances of leakage of rainwater or snow water into the home. Insulation on ceiling, crawl space, walls, exterior, and interior material choices can further prevent interior uncomfortable temperatures. Moving on to gas heating. There will be a kerosene-powered convection heater, such as from Dynaglow or Toyomi. This heater is expected to be used only during extreme cold weather events, which are going to be rare for this home's location. Gas heating is going to be the only type of heating other than natural greenhouse effect heating through the sun. And again, this location gets very few, very cold weather days, and this gas heater, of course, would work quite well during that time. It is a small heater, and this area again gets plenty of sun even during the winter, and the very few days that the greenhouse effect cannot be used, this gas heater I believe to be more than enough to cover any heating needs. Electrical air conditioning. I plan to have a 1300 watt total for electrical air conditioning. This is electrical cooling. There is an option this electrical air conditioning to have a heater. However, it is not necessary. That would be something that would be, again, optional and not really recommended if you want to be as efficient as possible. You may have a unit that has both air cooling and air heating, such as the one I have here. Further notes about this: air cooling must have a seasonal energy efficiency ratio, or SEER, of over 28 points, such as the Fujitsu AirStage LZ-AS1 series. The one I have here spec is a 9000 BTU mini split HVAC unit, which has a 31 SEER score. This particular unit is a 675 watt total electric cooling and a 1295 watt total electric heating. Similar units may be used. Only the living area of the house is to be air conditioned. And I have not shown a floor plan. I have not developed one, but I will. Perhaps by that time I will have that here in this presentation. But I plan the living area to be the largest area of the home, with bedrooms, kitchen, restrooms, of course, being smaller areas of the home. And this is planned to be a very small home, small overall square footage. I don't see why I would have any other air conditioning units other than the main living area. Again, only the living area of the house will be air conditioned. Rooms may have high window vents to distribute the air conditioning from the living room area to those rooms, meaning that you can have basically those holes or vents high up on the wall. They're like openings on each room where air freely travels in and out of each room, circulates in and out of each room. So you can have vents on the roof part of those rooms, and also some smaller vents on the lower area, so you can have a convection airflow go on each and one of those rooms. The kitchen equipment that is electric will total about 6,800 watts. I did my calculations on an app that I developed, which is basically a spreadsheet. So the items or equipment that will be on electric for the kitchen will be one electric 1000 watt microwave, one electric air fryer 1200 watts. This is a 4-quart air fryer. One small electric toaster oven 1200 watts. One electric blender 400 watts. One electric teapot 1500 watts. One small double surface electric grill 1400 watts. One electric ventilator hood for the kitchen stove range area, that is 100 watts. The kitchen will also have non-electric equipment. One LPG liquid propane gas range with an oven 20 inches wide. And again, I have sourced most of these items, and they have been located and priced. I should have also a estimate about the cost of each one of these and the total of all of these items, so I know more or less what it would cost to fully equip this home, fully build and furnish this home. That is what a specification sheet is. Basically a plan of the details of the place to be designed and constructed, the requirements, the electrical and energy demands, and also the cost estimates. This will all be done for this one project. Okay, we're continuing with the non-electric kitchen equipment. One aluminum caldero pot set. That's for cooking, of course. And I put that as equipment because they are vital for cooking on grills, charcoal grills, which I am planning to have, as I will mention here in this next few lines. One outdoor charcoal grill is part of the kitchen equipment that is non-electric. One LPG outdoor grill. And of course, on these grills, you can place a caldero pot for cooking anything. For those of you that don't know what a caldero pot is, it's nothing but a aluminum pot, which is very popular in the Caribbean, in Caribbean cultures and kitchens, because they are usually used on liquid propane gas stoves. Also, I will have one LPG outdoor turkey fryer, not only to fry turkeys, but to fry chickens, pork, fish, all kinds of meats, beefsteak, etc. Also, the last thing I have listed here, there may be more, but the last one I have listed here so far is a outdoor anafe charcoal grill. An anafe is basically a small charcoal grill that is very popular again in the Caribbean. You can have one or more placed outside. This is an outdoor piece of kitchen cooking equipment. It is somewhat similar to what they call in the US a hobo stove, which is basically a can where you put all kinds of combustible materials inside so you can cook on top of the can. But this is more elaborate. This is made usually with cast iron, and it has a cup shape like one of those, like the Stanley Cup, but a lot smaller. And just look one of those up if you're interested and curious what they look like. It is called Anafe, ANAFE, charcoal grill. Continuing on, non-electrical water heater. I will move on into water heating. Non-electrical first will include a central whole home unit to have plumbing for hot and cool water to serve kitchen, bathrooms, and all spigots and faucets. This will be a tankless water heater. I have specified here a Tagaki Series 200 Ultra Low NOx non-condensing outdoor tankless water heater of 6.6 gallons per minute. NG, that is natural gas, or LP, liquid propane. It could be used for either or. Of course, it could be something similar of different brand, make, whatever, but I believe that one to be a very good one. Moving on to the lighting, I have calculated 200 watts total. Electric lighting, of course, is all LED light bulbs in all lighted areas. Of course, that could change slightly. I am calculating about 10 lights of 10 watts each. Ventilation, I estimated to have a load of 220 watts total. Area fans used for ventilation, 2 fans. One would be a quiet 50-watt portable stand-up fan. I have sourced one here that's quite reasonable. We'll have 2 of those. And also we'll have 2 more fans that are ceiling fans, one in the living area and one in one of the bedrooms. These are to be 60 watts each. Office equipment, I have summed the total to about 290 watts. I will have one multi-purpose printer, 30 watts, one 40-inch HD TV, 60 watts, one laptop computer, 50 watts, and one desktop computer, 150 watts. And I have calculated those again using my what I call solar energy application. And of course, the wattage is an estimate of the equipment and the amount of time I use that equipment for, electric equipment. Shop equipment, I have a total of 350 watts. I will have 2 hyper-tough battery chargers going at any one point, 20 watts, one rigid battery charger, 100 watts, one Bosch 12-volt battery charger, 40 watts, one Bosch 18-volt battery charger, 70 watts, one Black & Decker 12-volt battery charger, 20 watts, and 130 PSI 5-gallon air compressor, 100 watts. There may be other shop equipment, but I did not put it here because I would probably use those very rarely, so it makes no sense to include those into the load calculations. Moving on to the laundry equipment. The washing machine will be electric, 300 watts, expected average use. Clothes dryer will not be electric, it will be LPG. So using those loads that I mentioned, the electrical load for the home is expected to be less than 10,000 watts. That is a very, very efficient home when it comes to electrical demand. On average, a home has a load of 20,000, 30,000, 40,000 watts. I believe 35 to 40 is about average here in the US. So having a home less than 10,000 watts, I have here a total of 9,460 watts. And that's not all. It gets better because that is the total watts that I would have if everything was running all at once, which is a very unlikely scenario. A more realistic scenario, I believe, would be a 65% or less of all of the home's electrical loads running at any one point or time. And these are expected to total only 6,149 watts. And I will move on to the next part of this chat. On the next video, I will break it up and I will discuss the electrical energy generator for the home. Also, I will discuss the water collection and distribution and recycling system. And I will also discuss the gas storage and distribution system for the home. Welcome back to the discussion on the efficient home project. Today is January the 8th, 2026. And picking up on the electrical energy generator for the home, the efficient home, the home will have a single primary source of electrical energy, a PV generator, solar PV module array, a lithium-based battery bank, and a central DC to AC inverter with associated switches, cables, and disconnects. The PV generator will be large enough to cover the electrical demand of the entire home and should have enough excess power and storage to cover power surges and sunlight unavailability. In the event of PV generator failure or the rare event of sustained sunlight unavailability, there will be enough non-electrical systems for home residents to remain safe, comfortable, happy, and productive during any such event. So again, the generator is going to be capable of producing, this is again a PV solar generator, which is the combination of solar panels, the equipment that go along with it, the battery system that goes with it, charge controllers, and the inverter, and other equipment that may be necessary, such as disconnects, cabling, switches, fuses, or circuit breaker panels. The load of the home is 9,860 watts, and about 65% or less of the home's electrical loads are expected to be running at any one time, which equals to 6,409 watts. Just to continue here, per the Off-Grid Solar Energy Calculator, which is an app that I developed using simple Excel sheet, the home watt hour requirement is about 17,200. And the battery system, which is to consist of 6 each of 200 amp hours, 48 volt DC AGM type SLA batteries, which make altogether 19,200 watt hours of energy available. And again, the batteries each is 200. Of course, 200 times 6 is 1,200. But you have to multiply the 1,200 by the amount of hours per day that you have available. And on average, we get about 4 hours of charge time, sunlight in this area, which equals to 4,800 watt hours. So I am not really sure where I got that figure of 19,200. Let me find out. Open the application. I should have those figures saved. It was my error. The formula here says that I am to multiply each of the batteries amp hours by each of the batteries voltage, which in this case they are 48 volt batteries. So 200 times 48 equals 9,600. Divide that by 3 according to the formula. 3,200 times 6 is 19,200 watt hours. The 3, I'm guessing, is the number of hours that I will be using it. That is the figure I come up with, 19,200 watt hours. Again, the home watt hour requirement is only about 17,200, so I'll have over 1,000 watt hours to spare using the 19,200 watt hours, about 2,000 actually watt hours to spare. The solar PV module array is planned to be a 14 module of 350 watts each, totaling 17,150 watt hours. That is with the 3.5 hour per day yearly average of insolation. The PV module array is to be mounted on the south face of the roof wall above the window top line, or allowing space for the window. There's a window planned to be on that south facing side of the roof, perhaps both sides. And again, this is a roof wall, I call it, since it acts both as a roof and a wall. The central inverter's running output should total to about 10,000 watts to provide excess capacity. You may opt for a multi-inverter setup that can total 10,000 watts, such as 5 each, having 2,000 watts per inverter. Of course, 5 times 2,000 is 10,000, and you could break down each inverter by, let's say, areas of the home, rooms, or by application. Maybe one inverter is to run your refrigerator, the other one is to run your shop machines, the other one is to run your vacuum cleaner and microwave, etc. You may break down their use in a breaker panel, circuit breaker panel, and label those, and label each inverter as to what their application is, what they're being used for. Moving on to water distribution. Rainwater collection. The main source of water may be a rain collector container, 30 foot long, 1 foot wide, and 1.5 foot deep, given a volume of 45 cubic feet or 336 US gallons. The water collector is to be placed outdoors near the roof runoff water line to collect rainwater. This water is to be used for watering plants, washing, and bathing only. But a portion of this water may be treated for drinking. Collected rainwater may be pumped for washing in bathroom and kitchen. Drinking water will be placed on 3-gallon bottles. Treated and filtered drinking water will be placed on 3-gallon bottles to be dispensed at a water dispenser near the kitchen or in the kitchen. Water treatment. A water treatment system may be installed as an option to purchasing drinking water. Collected rainwater may be treated using this system for drinking. A whole home water filtration system has its own energy requirements, and installation and maintenance costs may be high. I estimate that the system daily electrical energy draw may be similar to that of a household refrigerator, and I do have a link to a sample or an example of a water treatment system. This particular one is a Pro Plus Aqua Elite bundle of 20 gallons per minute multi-method hard water whole house water filtration system, and it is available at Lowe's. Exterior layout. The tankless water heater shall be installed on the north side exterior wall to minimize direct sunlight exposure to the system. The energy system battery bank shall be installed on the north side exterior but under the floor line to minimize direct sunlight exposure and allow for ventilation. The solar panel array shall be installed on the south side exterior roof wall to maximize direct sunlight exposure. And these, again, the exterior layout I'm discussing, these are just the exterior components of the home to be installed in what locations approximately. So continuing on, the water collection pool shall be installed on the north side of the roof, on the north side of roof wall. It may be rectangular, running the length of the roof wall at ground level. It may be, for example, 30 foot long and 1 foot wide, placed so it can collect the runoff water from the north side of roof wall. It may be an above ground water sealed concrete structure or a special made cast plastic container. The structure or container may lay on the ground at grade level and take minimal footprint space. The solar module array is to be roof mounted on the south side of the roof wall. Solar switching and other equipment will be mounted on the north side of the structure on its freestanding roofed wooden panel. So again, this explains how the PV array is to be mounted on the roof, and the equipment that operates that array is to be mounted on the north side of the house on a freestanding structure that is to be roofed, basically covered. And I go into the interior layout. The interior layout will consist of a main space subdivided into 3 separate areas or rooms. The dividing walls may be Japanese style paper and balsa wood divisions. The larger area may be in the center, while the kitchen and bath may occupy 1/3 of the entire space, and the 2 bedrooms on the other 1/3 of the entire space. Bedrooms will be small and well organized to make maximum use of space. Kitchen and bath will also be small and with maximized space utilization. There will be minimum space for storage. Small appliances and furniture will be provided. Beds, tables, and couches may be folded away for better use of space.
The general layout will accentuate open spaces and make efficient use of vertical and horizontal space to aid in the goal of efficient use of space.
And that is an introduction to the Efficient Home project. Do look at the plans, drawings, sketches, and renderings and photographs or pictures and art that could further explain, describe all of the design features of this efficient home. Thank you very much.